The last two videos for this section have to do with solving rational inequalities in one variable. So you're going to have P over Q greater than 0, P over Q less than 0, P over Q greater than or equal to 0, or P over Q less than or equal to 0. That's called a rational inequality, where P and Q are polynomials, right? So basically the procedure would be, first find where P of x equals 0, graph on the number line with an open dot if you have a less than or greater than, and a closed dot if it's less than or equal to or greater than or equal to. These are going to be the endpoints of your intervals. You're trying to see where is that rational expression positive or negative, and you want to know where it's 0. The second, you want to find where the denominator is 0, because thus asymptotes or a hole in the graph, and in those cases it could jump from positive to negative or negative to positive without passing through the x-axis. Okay, so we need to know where the numerator is 0 and where the denominator is 0. When the denominator is 0, you always have an open dot. The reason is because you can't divide by 0, so the point where you would divide by 0 can't be a solution of the inequality, okay? Because it doesn't make any sense. You're dividing by 0. So then you test values of x for each region defined by the endpoints found in 1 and 2, and shade each interval in which the test values satisfy the inequality. Okay? And then number 4, write the shaded regions from 3 in interval notation. They usually want the answers in interval notation. Since there's often more than one interval, it can be difficult to write, or somewhat confusing, at least at this level, to write in algebraic form. So they have you write them in interval notation, which is good practice anyway.